Alright, so excuse me, as we are doing our roots and radicals, this next set of notes is going to be working on the equations versus square roots, equations with square roots. And so we do have a little bit of tidbits of reminders up on the top that if you have a square root, basically that's the same thing as x raised to the power of 1 rooted 2, which is 1/2. 1/2, when you square the square root, you simplify down to just breaking the x out and by itself. So kind of keep that in mind, because that's what we're going to be, that's going to be an essential component to each one of these equations. So with step 1, when it comes to solving your equations that have square roots in them, solve until you get the actual radical sign itself. Step 2, raise both sides of the equation to the power of that root. So if you're dealing with an actual square root, then you're going to raise that entire square root and whatever's on the other side by 2 to the power 2, and thus breaking it out. And that way, when you plug the 25 back in, you have a true statement that says the square root of 25 is 5. That is true. Okay, and if needed, if there's still more underneath your root, then continue to solve for x. So those are the 3 steps that we're going to be looking at. The important thing is to remember that you're going to solve like you would any other equation to get down to that radical. If you're not familiar with the ones with absolute values or anything along those lines, it's the same basic process. You're going to use the same reverse order of operations to solve for what would be x, but now we're just solving to try to get the radical by itself, which usually contains our x anyways. So step 1. Here's our example 1. So we have our x plus 2 equals 5. The square root of x plus 2 equals 5. We're going to use the subtraction property of equality on both sides, just like we would in a regular equation. But then, where this would be my stopping of my normal equation with the square root, I then have one additional step, which is to square both sides. So now I have x equals 9. So the square root of 9, which is 3, plus 2 equals 5. True statement. So again, I have my next example. What if you have something that looks like this? Well, if I was over here and over here, I'm going to do the exact same process as if this was a normal equation. Don't overthink it. So again, I'm going to start with my subtraction property of equality from both sides. Obviously, if that was a minus 4 to begin with, I just use addition property of equality on both sides. Leaving me with 2x equals 6. Same thing over here. 2 times the square root of x equals 6. I use the division property of equality on both sides and both equations. And where normally I'd be done, I have my one extra step over here, which is now that I've gone to the square root of x is 3, then the question is, well, what was x originally? So when I rooted it, I got 3, and to find that out, I had to square both sides. So x equals 9. So when you see these, envision this, and when you get here, do that. And that's all you have to do. It is not a new process, it's just one new step. So let's look at our next example. Okay, now if you notice, this one gets a little bit more complicated. I now have x plus 4 inside my parentheses, which is, in this situation here, inside my radical sign. And so, but that initial concept of these are being grouped together first, if I was actually going to do true order of operations, then in this situation here, I would add 4 to x first, before taking the radical and multiplying by 5. Up here, I take the radical, times it by 2, and then add by 4. Excuse me. So, since it is what would be my first thing to do if I'm solving the equation and actually simplifying it, it's going to be one of the last things I do now that I'm solving for x. So, since these are attached by multiplication, you undo those by division property of equality. Please note that 4 is included into the root. That is an important component because that means it falls into this parentheses process. And once you've done that, then you basically break it out of the parentheses, and we are left with here. And so this is a slight deviation between the two. Normally over here, I just keep solving and get my answer. But over here, my next step is actually to square both sides. And so I have this inserted step to undo that square root, to square both sides. But then after that, just like here to here, now I'm going to go back to solving the equation for x. And I get my answer. It is important to note that even though this is an x plus 4 inside of here, that the x plus 4 works the same way as breaking the x out. The x plus 4 is unchanged. Okay? It's because all of this was being rooted, so all of it when squared, all of it breaks out unscathed by being squared. That is an essential component to remember. Whatever's inside the radical is freed. Okay? Then we subtract and we get our answer. So let's look at some other little examples. So if I had x to the third equals 27, then how do I undo raised to the power of 3? Taking the cube root of 3 by 3. And so we would actually cube root both sides to get our answer. So that concept goes both ways. If I already had something that was rooted to the third in a cube root, I can raise it to the third to both sides. All of this radicalness disappears, and I get x equals 23. Or excuse me, x equals 27 when you take the cube root. Now, this is one where I do want to make sure I threw this in so you had it. Traditionally, on a normal equation, if you ended up with a negative integer, then you're like, okay, no big deal. X equals negative 3. But if you actually have something like that with a root, a square root sign, your answer is actually going to be no solution. If you were to graph the square root of x and graph negative 3, then their lines would not intersect at all. And so that indicates the fact that there's actually no solution if you get this negative sign. And that's always a great default. If nothing else, graph the left, graph the right, see what happens, and if they see how many times they intersect, or in this situation, don't. All right, so those are some examples of equations versus equations with square roots and how to be able to solve them. I hope these notes help.